Now, in this video, we're going to answer the following question. Find the turning points of the cubic function below and determine their nature. And we've been given the function f of x equal to x cubed minus 3x squared plus 2. If you find this video helpful, please consider leaving a like, a comment, and subscribing to our channel for more content like this. A cubic function is a polynomial function of degree 3. The graph of a cubic function can have two turning points. A turning point is a point on a graph where the function changes from increasing to decreasing, or vice versa. A turning point is also known as a stationary point. So, to answer this question, we're going to use a 5-step process. First, we need to differentiate the cubic function and set it equal to 0. Then, solve that equation to find the x-coordinate for each turning point, and substitute those values into the function to find the corresponding y-coordinate. Then we need to find the second derivative and substitute each value of x into that derivative to find the type of turning point. So let's begin by finding the first derivative. If f of x is equal to x cubed minus 3x squared plus 2, we need to differentiate each term to find its derivative. We do that by multiplying the coefficient of each term by its exponent before reducing the exponent by 1. So x cubed becomes 3x squared and minus 3x squared becomes minus 6x and 2 becomes 0. So the first derivative f dash x is equal to 3x squared minus 6x. For further explanation of how to differentiate a function, search our channel for an explanation and more examples. Setting 3x squared minus 6x equal to 0 and factorizing to get x multiplied by 3x minus 6 equal to 0, we can identify two solutions. The first, when x is equal to 0, and the second, when 3x minus 6 is equal to 0, which we can solve by adding 6 to both sides. So 3x is equal to 6, and dividing both sides by 3. So x is equal to 2. Substituting both values of x into the cubic function we started with gives us the corresponding y coordinate. F of 0 is equal to 0 cubed minus 3 multiplied by 0 squared plus 2, which is equal to 2. So 0, 2 is the coordinate pair of the first turning point. F of 2 is equal to 2 cubed minus 3 multiplied by 2 squared plus 2, which is equal to 8 minus 12 plus 2, which is equal to minus 2. So 2 minus 2 is the coordinate pair of the second turning point. Next, we need to find the second derivative. We do that by differentiating f-x equal to 3x squared minus 6x, the same method as before. 3x squared becomes 6x, and 6x becomes 6. So f double dash x is equal to 6x minus 6. To find the type of turning point, we need to substitute the x coordinate of each turning point into the second derivative. F double dash 0 is equal to 6 multiplied by 0 minus 6, which is equal to minus 6, which means that 0, 2 is a maximum point. F double dash 2 is equal to 6 multiplied by 2 minus 6, which is equal to 12 minus 6, which is equal to 6, which means that 2 minus 2 is a minimum point. So the answer to this question is that there are 2 turning points. One with the coordinate 0, 2, which is a maximum point, and the second, which is 2 minus 2, which is a minimum point. If you found this video useful, please consider leaving a like, a comment, and subscribing to our channel. Thank you.